Good morning, everybody. We're going to review what we should know by now. Just a quick review of everything we've covered so far. We've started off with ratios. We were doing the shark tagging studies and some other population problems that involved a ratio. A ratio is a comparison of two things. So if 3 out of every 5 kids say, "Yeah, I would vote for a longer lunch," even if it meant I had to stay at school a little longer, if 3 people say yes out of every 5 total, we're comparing two things: the people that say yes to the total number of students. You also did this with animal tagging. Maybe 3 animals were tagged out of 5. So a ratio is comparing two things. Maybe that's the amount of strawberry slices to strawberry slices in a smoothie. Anytime you're comparing two things, that's a ratio. If you try to find another equal ratio to that ratio, now you're making a proportion. If you're trying to find two equal ratios, that's going to be a proportion. So if 3 people say, "Yeah, I would vote for a longer lunch," out of every 5 total kids, well, how many can we expect to say yes out of 100 total kids? What we're going to find now, we're going to make a proportion, and hopefully you remember a couple ways to solve this. One way that always works is to cross multiply the numbers that are diagonal, cross multiply, and then divide by the number that's left. So 100 times 3 divided by 5. Or if you see a shortcut, you can use the shortcut, but there won't always be a shortcut. So you can always cross multiply because there won't always be a shortcut. But if there is, go ahead and take it. So we can assume that 60 students out of 100 would say yes. So ratio, comparing two things, writing it as a fraction, and a proportion, two equivalent ratios. Okay. Beyond that, we've started working on the distributive property. We think about the parentheses as what's inside of the box, and the number outside the parentheses, how many of those boxes did you buy? So here I have 5 PlayStations and $2. It's easy if you think of numbers by themselves as money. So in the box, there's 5 PlayStations and a $2 coupon. And you buy 6 of those boxes, 6 of those parentheses. What are you going to end up with? So I encourage you to draw your arrows to both right away, because you've seen it's so easy to forget to do this second part. We know we're going to have 5 PlayStations 6 times, so that'll be 30 PlayStations. And then a lot of times kids just write +2. So again, go ahead and draw your arrows so you don't forget. You go, "Oh yeah, 6 times I'm going to get $2, a $2 coupon. So that's going to be $12 coupon." And then you're done. Okay, distributive property. We've also worked on negative numbers a bit. If 5 times you lose $2, again, think of these numbers as dollars when there's no variable, when they're by themselves, especially with negatives. If 5 times you lose $2, well, then you've lost $10. Okay. And then if we do the two negative numbers multiplied, the opposite, you can think of negative as opposite. The opposite of 5 times losing $2. What's the opposite of 5 times losing $2? Is 5 times winning $2. That would be a positive 10, which we would just see or write as just regular 10. That's assumed it's positive. Now, if you're adding, combining, subtracting negative numbers, that's going to be a little bit different. If I lose $5 and then I lose $2 more, tell yourself those stories with money. If I lose $5 and then I lose $2 more, I've lost a total of $7. Okay. The tricky one will be something like that. I lose $5 and then I find 2 of them. So 5 of them were lost, but then I found 2 of them. So how many are still lost? I've still lost $3. If I owe you $5 and then I find $2, I give them to you. Are we good? No, I still owe you 3. This will be, you can tell yourself stories, or you can make sure you use a calculator for these trickier ones. Okay. All right. That's just a summary of what we've learned so far this year and what you need to know. So study up.